Today we will look at applications of deep learning in vision. Can you tell me what are the models in deep learning? Can anyone tell me what are the models in deep learning? Yes, students, anything you know about deep learning? Rakesh,
Yeah, ma'am.
tell me anything you know about deep learning.
Yes,
Hmm?
ma'am.
Yes, yes, Rakesh. Tell
Online.
me anything, something. Okay. So the deep learning has got several models. It is nothing but a neural network, structure which has got uh, a very good, strength to capture, to identify, to recognize so many details of a image or text. Deep learning can work with image or text. For image, the main models are CNN. For text, the primary model is RNN. In this class, we will look at the applications of deep learning in vision. In vision means uh, CN. Mainly, we will deal with CNN. So, applications in computer vision. Applications of deep learning in computer vision. So, the first application is object detection. Next is face recognition. Next, action and activity recognition. Human pose estimation. These are all applications of deep learning in computer vision. Let us look at object detection first. What is object detection? It is the process of detecting instances of semantic objects of a certain class. When you have in an image, look at this. This is an image. In this image, there are several objects. What are the objects? There is a car shown here. There is this bike. On this bike, there is a person. That is another car. This is road. Like that, different objects are shown in this. And the job of a model, deep learning model, is to detect an object that belongs to a certain class, like humans or airplanes or birds, and detection of objects in videos as well, not only images, in videos as well. So a common approach for object detection frameworks include creation of a large set of candidate windows that are in the SQL classified using CNN features. You create CNN architecture, you extract the features of a image from this image using CNN, and then you try to label each object that has been identified. There is lot of research uh, in the field of this object detection. This reference 32 at this 30, the paper number 32, this 32 paper, they have done rich feature hierarchies for accurate object detection and semantic segmentation. In this, that that has employed selective search. This method is described in and employs selective search in another paper to derive object proposal, extract CNN features for each proposal, and then feeds the feature to an SVM classifier to decide whether the window include the object or not. These are the techniques, different techniques for object detection using CNN. A large number of works is based on the concept of regions. The CNN feature proposed in, you know, this image has got regions. Based on the regions, this like this, we can divide this image into regions. A large number of works is based on the concept of regions, and approaches following the regions with CNN paradigm usually have good detection accuracies. Example is paper number 61 and 62. However, there is a significant number of methods trying to further improve the performance of regions with CNN approaches. Alright, there is significant number of methods. You have got several methods, and they are trying to improve the performance of regions with CNN approaches. And they are also trying to find the approximate object position. The problem that they face is they cannot precisely determine the exact position of the object. And to solve this problem, a joint object detection semantic segmentation approach was presented in the article 64 to 66. If you refer to references 64, 65, 66, you will find a joint object detection semantic segmentation approach for determining the exact position of the object. In the first image, you can see that there is this helicopter. So helicopter is an object. There are trees. Trees are objects. Here you see that there are horses. You can see this bounding box. This is known as bounding box. These boxes. These boxes will uh, encompasses or encloses the object. So this is one object. This box denote that this is one object. This box denote this is another object. This box denote that this is another object. So all these articles have tried to explore this object detection method using several approaches. Object detection paper number 70 proposed a coarse object locating method based on a saliency mechanism in conjunction with a DBN for object detection in remote sensing images. And article number 71 presents a new DBN for 3D object recognition, in which the top level model is a third order Boltzmann machine trained using a hybrid algorithm. And paper number 72 employs a fused deep learning approach. 73 explores the representation capabilities of a deep model. You can you can try to read these papers to get a detailed understanding of how an object is detected using different approaches. Next application of deep learning is face recognition. I think you know that we can tag a person in this Facebook. When you tag a person in the Facebook, then what happens is uh, that Facebook will identify that person later. If that person is they in it's all about identifying a person face. That is face recognition. It has got a great commercial interest as well. And there several face recognition systems were developed based on handcrafted features uh, presented in paper 76 to 79. And feature extractor extract features from an aligned face to obtain a low dimensional representation based on which classifier makes prediction. Okay, images are not given, but I will show you how it happens. like this. This face is recognized. The model will find all these different elements of the face. Look at this: eyes, nose, mouth, lips, and this the uh, length from eye to mouth and from nose to this mouth. All this will help in recognizing the face. Look at this, how this face is modeled. So here there is one more example. These points will designate different parts of the face. Here it gives the size of each of the parts, and through this the application can recognize the face. Google's FaceNet. This Google's FaceNet and Facebook's Deep Face. These are the prominent face recognition models developed at Google and Facebook respectively. And these models can precisely identify the face of a person. And these both are based on CNN, convolutional neural networks. Google's FaceNet and Facebook's Deep Face. Both are based on convolutional neural networks. The normalized input is fed to a single convolutional pooling convolutional filter followed by three locally connected layers and two fully connected layers used to make the final predictions. DFace has attained great performance rates. Its representation is not easy to interpret because of the faces of the same person are not necessarily clustered during the training process. And on the other hand, FaceNet defines a triplet loss function on the representation, which makes the training process learn to cluster the face representation of the same person. This implies that uh, deep face is good at recognizing the face very well, but it's not easy to interpret it. And this FaceNet, which is um, developed by Google, it defines a triplet of loss function which makes the learning process learn to cluster the face representation of the same person. Same person face would be different from different angles. So then we have to cluster it. If this is front face, there may be side face, and at different angles. And you can have different expressions on the face. Different expressions would give um, slightly different look of the face. So all this is implemented by these giants, technological giants, Google and Facebook. And the important point here is that both the models uses CNN, convolutional neural network, which is a deep learning model. The third application is action and activity recognition. Let me show you some figures. Action recognition. Look at this figure. This man has taken out his pets in the garden. So that is the action. This human action. Or there can be a man running or doing different activities, playing, doing gym, dancing. Here you see this action recognition. Which player is doing which action? Human action and activity recognition is a research issue that has received a lot of attention, and it is not easy. It's extremely difficult task to identify the action and activity of a person. Being said that, um, it is also successfully done in deep learning through CNN based model. So the authors in paper number 90 has successfully employed a CNN based approach for activity recognition in beach volleyball and event classification from large scale video dataset. CNN model for activity recognition based on smartphone sensor data. So here also you have CNN based models for activity and action recognition. Next, next one is human pose estimation. Human pose estimation means a human can sit, can stand. You know there are different poses. That identification is typically done through human joints from images, image sequences, depth images, or skeleton data as provided by motion capturing hardware. Okay, so human pose estimation can be accomplished through this deep pose. This is a holistic method that formulates the human pose estimation method as a joint regression problem and does not explicitly define the graphical model or part detectors for human pose estimation. This deep pose, this is also a system developed, okay, in the referenced article number 14. They have formulated human pose estimation based on a method of joint regression problem. Regression, okay, and then uh, in article 15 authors have trained the network using the whole image by using the local part patches and background patches to train the CNN in order to learn conditional probabilities of a part presence and spatial relationships. So in this, author is training the network, CNN network, using the whole image, but then they are using the local part patch. They are identifying the patch. Patch means what? Here, this is human. You just take patch of this and this and this, and patches you can take for other parts of the image as well. So using this patches, local patches, and a whole image. Authors have trained a system and they could identify the human pose. Next one is a data set. What do you mean by data set? All these um, applications of human pose estimation, action and activity estimation, face recognition, object detection, all can be done if you have a data set. A data set is required to train the model, and then the model is made to learn through the data set, followed, and subsequently model will identify uh, or perform the task of object detection, face recognition, on a entirely new image. So that is all data sets. And images can occur in grayscale format or in RGB natural images format or in hyperspectral images, facial characteristics images, medical images. All these are the different kinds of images, and when you collect together all these, they form the data set. Okay, this is all about deep learning in vision. Uh, any doubts in this? Okay. Okay. Okay, then the last topic left is deep learning in speech. Tomorrow we will complete it. Bye.